It'll begin with a series of rocket launches from Earth. Each powered by more than 10 million pounds of thrust, delivering some 50 tons of people and provisions beyond our atmosphere. Once a spacecraft leaves Earth's orbit, it'll be some 8 months before it reaches Mars' orbit. Then, finally, a white-knuckle plunge toward the surface of the red planet itself. This is how our human civilization will begin on Mars. Once there, we'll harvest water, build our homes, grow our own food. We may even attempt to raise children on Mars, tempting our bodies to evolve traits we would never find on Earth. But the vision for a future on Mars began even before the birth of NASA or the European Space Agency. That vision began nearly a century ago, connecting Nazi war machines to a nearly forgotten space race and a series of epic launchpad failures to a series of blockbuster discoveries on our nearest neighbor.
Today we're going to announce that under certain circumstances, liquid water has been found on Mars.
This is the story of how we took our first steps toward becoming Martian.
Mars is basically our cold little sister.
It has about half the diameter of Earth, which means it has about 1/3 the gravity that we experience here on Earth. And so that atmosphere is mostly carbon dioxide, but it provides very little greenhouse effect. And so the swing from daytime temperatures to nighttime temperatures can be around 100 degrees.
The air can't be breathed and the pressure isn't correct. The dust could be toxic.
And to top it off, its surface is bathed in radiation. Mars is a planet that was not made for humans. Yet, less than 100 years ago, some scientists still held out hope that it could be home to another intelligent species.
From the mid to late 1800s, when telescopes were developed that were good enough to see the surface of Mars, people were dreaming about the civilizations that could live there.
People like Nikola Tesla and others were wondering if perhaps some of the structures that they thought they observed on Mars, things that appeared like lines that they interpreted as canals, might be an indication not only of life on Mars, but perhaps sophisticated sentient beings.
There would be zones that were dark some years and light other years. We now know those were due to giant global dust storms, but at the time, they were convinced that that was indication of plants growing in different locations or some kind of storms.
To many, Martians were engineers who had built a network of canals so massive they could be seen from Earth. And then came the breakthrough that would finally put Mars not just in view, but within reach.
They now realized what sort of terror weapon they were up against, and that they had no defense whatever against it.
World War II, Germany's V-2 ballistic missile transforms how wars are waged and teases a future beyond our atmosphere. It's a brutal, destructive entry into the space age. After the war, the architect of the V-2, Wernher von Braun, along with more than 100 German scientists and weapons engineers, were spirited out of Nazi Germany and into the United States to continue their controversial yet groundbreaking work for their former enemies. But in his spare time, von Braun's thoughts were elsewhere.
Wernher von Braun in the 1950s was inspired to write out specific plans for how we could reach Mars and settle a colony there.
His detailed notes consider everything from crew safety to the amount of cargo that could be carried between planets. He would share his vision first in a book and later in a Disney primetime special.
That will make possible the long trip to Mars with only a small expenditure of fuel.
950 rocket launches would deliver astronauts and materials into low Earth orbit, where an armada of Mars-bound spaceships would be constructed by spacewalking astronauts in a weightless assembly line.
This unusual ship will be 500 feet across and will carry a small landing craft for the final descent to the Martian surface.
Each detail of the mission was carefully choreographed around the alignments of Earth and Mars.
And it's only really feasible to do that about every 2 years when the Earth and Mars are relatively close together in their respective orbits.
When the planets reach their ideal alignment and are separated by just under 60 million kilometers, von Braun's astronauts leave Earth's orbit and head for Mars, a 260-day trip.
When our ship reaches Mars, the landing craft will be released, carrying men and supplies to the planet's surface.
By the time the astronauts returned to Earth, they'd have been free of Earth's gravity for 969 days. Over 500 days longer than the current record for the longest mission in space.
Von Braun was thinking really far ahead of his time.
Von Braun's vision captured Americans' fascination. A plan for permanently settling on Mars was still a ways off, but exploring this new frontier felt not just possible, but imperative. The first race for Mars had begun.
The US and Russia were competing to get rockets in space, and they were working as fast as they could to develop new technology to do things that just had never been done before.
By 1960, the Soviets were on a major winning streak, having been the first to put an animal in space and the first to launch a satellite into Earth's orbit. It wasn't anywhere near the scale of what von Braun had envisioned. But in October 1960, the Soviet space program makes 2 attempts to be the first to Mars. Both fail. When the launch window reopens in '62, the USA joins the effort to leave Earth. On this year, though, NASA's Mariner program is heading for Venus instead of Mars. Mariner 1 fails to reach its destination. Then, Mariner 2 performs a flyby of Venus as planned, becoming humanity's first successful mission to another planet. With 3 more failed Soviet missions, Mars remains out of reach. When the launch window opens again in late 1964, the race for Mars is running red hot. 3 probes will be launched in a span of just 4 weeks. 2 more fail. And then there's Mariner 4.
You get to launch day when there's one of the highest risks of failure in the mission. Sitting there watching a rocket launch when that's a project that you've worked on for years and you're excited to see happen is so exciting. It's just this thrilling moment and also terrifying.
And there's nothing quite like that sound when something gets tossed out into space off our planet.
Mariner 4 has a clean launch and is sent on its way to Mars.
Equipped with a telescope and a television camera, Mariner 4 headed for Mars. Its mission? To take close-up pictures, which would, hopefully, resolve the mysterious wave of darkness and other unanswered questions.
On board, a collection of sensors that will reveal the true nature of the condition on Mars. And most importantly, a camera with enough processing power to send 21 pictures back to Earth, if the mission goes to plan.
There's so many perils in the solar system, not just with your machinery, but the solar system itself is spewing out high-energy particles, not just from the sun, but from other galaxies. And those can disrupt communication or instruments aboard your vessel.
Speeding through space at more than 10,000 miles per hour, guided by the star Canopus, Mariner 4 approaches Mars on July 14, 1965. It's been zipping through space for 8 months, and now it'll have just one day to photograph and probe the planet before cruising past it and entering the sun's orbit. The scientific team back at the Jet Propulsion Lab in Pasadena, California, can do little more than wait to see if their mission has been successful. Then, the sound they've all been waiting for. It'll take days for computers to convert this digital code into images. Far longer than it would take a trained scientist to do the same.
They started coloring in squares based on the little bits of data they were getting back so that they could see the pictures that were being returned piece by piece.
In all, Mariner 4 photographs around 1% of the Martian surface and reveals a landscape as parched, cratered, and as empty as the moon's.
When we see the Mariner 4 images for the first time, it really made people realize that Mars is not a living planet.
The scientists who have examined Mariner's pictures are not yet willing to identify any of the controversial canals. These and other conclusions about the planet's surface will have to come later.
Its onboard sensors capture for the first time the troubling data that still haunt Mars mission planners today. Daytime temperature readings of minus 100 degrees Celsius, air pressure less than 1% of Earth's, and the absence of a protective magnetic field, which leaves the planet exposed to intense radiation.
They know now that the planet is even more inhospitable, more desolate compared to Earth than it was thought to be.
I think it's possible that people could have seen the images from Mariner 4 and decided, you know what, it's not worth spending any more time or resources exploring Mars or even trying to have humans reach Mars. But luckily, that's not what happened.
Clearly, humanity kept focus on Mars, even if it didn't completely understand what it was looking at.
This is the theory. If the Martian atmosphere contains carbon dioxide and methane, and they are exposed to the ultraviolet radiation of the sun, they may produce sugar. In other words, there may be a constant sugar fall on Mars.
Each of the dozens of missions to Mars since the 1960s has sharpened our view of the red planet. While the data about its climate and radiation load is as daunting now as it was in 1965, what we now know about its water resources gives us far more hope about our chances of visiting or even settling there. In 1976, Viking, our first operational Mars lander, gave us our first view of the Martian surface from the Martian surface. To the trained eye, the images of the hardscrabble landscape told a story of ancient riverbeds and floods. It's a story that we now understand well.
Around 3.5 to 4 billion years ago, Earth and Mars probably actually looked very similar. Both had liquid water on the surface in the form of rivers and lakes and possibly small oceans. And yet, over time, Earth retained its water and kept this thick atmosphere because it has a magnetic field that protects it from the solar wind. And Mars was very small and didn't have that magnetic field and slowly lost a lot of the water to space.
The discovery that water had once flowed over the surface of Mars rekindled hope that there could still be water somewhere on the planet.
0 and lift off.
That mystery would be solved some 30 years later by another NASA robot, the Phoenix Lander.
Touchdown on the ground safely.
The basics of what it discovered can be demonstrated with simulated Martian dirt, or regolith, and a chunk of store-bought dry ice.
This is dry ice. It's CO2 in the form of ice, which you can see is sublimating to form a gas. So it's going straight from a solid state to a gaseous state because CO2 is stable as a gas in our atmosphere. Water on Mars in the extremely thin CO2 atmosphere that's present there is stable just like this dry ice is on Earth. It's only stable as a gas, basically, and up near the poles, it's stable as ice. And so ice in the mid-latitudes of Mars would behave just like this CO2 ice behaves here.
In other words, most of the surface water ice on Mars would have long since sublimated into water vapor, the way dry ice turns straight to vapor here on Earth.
However, there is some ice on Mars in the mid-latitudes that's protected. So it would be just like if we had this CO2 ice and we protected it by covering it up with the Mars regolith. And so if there's a thick enough layer of regolith over the ice, it can actually protect it for an extended period of time on Mars. You can see there's actually a lot less vapor coming up off it. There's a lot less CO2 gas escaping, just like on Mars, where some of the water ice is protected under layers of dirt.
In 2008, NASA's Phoenix Lander performed a similar experiment up near Mars' polar ice cap with a similar result.
There's not water ice exposed at the surface like this, but there is water ice just below the surface, covered in a thin layer of regolith.
Using its robotic arm, Phoenix scraped off the top layer of Martian dirt, exposing what looked like subsurface ice. 2 pictures of that scrape, taken 4 days apart, told scientists all they needed to know about what that material was.
So it'd be just like removing the dirt here and leaving a chunk of ice out on the surface. Now you can see that as soon as the ice is exposed, it starts sublimating again, and there's a lot more vapor coming off of this chunk of ice. Similarly, with the Phoenix mission, when we exposed a chunk of ice, it actually disappeared.
Only one substance would sublimate on Mars' frigid, low-pressure surface like that: water ice. For those dreaming of settling on Mars, Phoenix's discovery was a game changer. Water ice means water to drink, water to grow crops, water to be broken down and used for rocket fuel and oxygen. And we now know that water ice doesn't just form below the top layer of Martian regolith. Microscopic traces of water ice can also hide within the seemingly dry regolith.
So we did a little experiment here. We froze just a little bit of water with some of the regolith, and you can see from this why it's hard to find even small amounts of water on Mars, even though it is there. So these 2 glasses look very similar, nearly identical, but the little tiny bit of water in one, as we put these 2 glasses out here in the sun, will actually condense around the edges of the glass.
For as long as we've been studying Mars, water has been in the picture. It's only in the last few years, however, that we've really been able to see it.
It's a discovery we just keep remaking. All throughout my career, I've heard about, oh, we just discovered water on Mars. Again, in a new way, at the poles or in these sediments or possibly in these structures that we see on the side of sand dunes.
Mars has very little water compared to Earth, but there actually is a lot of water ice stuck at the poles of Mars. So if you add up the North Pole and the South Pole, and if Mars were a perfectly round marble and you put all of that water as liquid water around Mars, you would actually have a global ocean about 22 meters deep around the entire planet's surface.
And now, we even have proof that liquid water exists deep below the surface of Mars' poles.
We are here today to present you our results and the fact that we have found liquid water on the subsurface of Mars.
There may not be canals on Mars, but there are natural reservoirs of water and ice. Resources that Wernher von Braun and the architects of the Mariner mission could never have imagined. With that water, we now know that not only is there a chance that life can exist on Mars, there's a chance that human life can be supported long-term on Mars. But for humans to become Martian, we're going to need to do more than just mine water from Mars' frozen ground. We're going to need to source food and shelter for our Martian settlements on Mars itself. All while the deadly conditions on Mars challenge the strength of our bodies and take aim at our fragile genetic material. Getting humans to Mars may take about a century of effort, but it'll be just the first step in our quest to become Martian.